Chapter 9, The Time Value of Money. This is one of the most important chapters in this class as far as comprehension is concerned. While most students are generally familiar with the concepts of future value and present value, you often lack the ability to identify and categorize the nature of the problem before you. The material in this chapter serves as a springboard to the remaining chapters in this section on valuations, cost of capital, and capital budgeting topics. A good background in time value of money will ease the transition, hence the prerequisite for this class. I find from my CFP days of study at BU that calculating present values and future values with that visual orientation helps to master the concepts. I hope you enjoy this chapter. So what will we study? Our chapter outline. Money has a time value associated with it, and therefore a dollar received today is worth more than a dollar received in the future. You should have heard that one before. The future value is based on the number of periods over which the funds are to be compounded at a given interest rate. The present value is based on the current value of funds to be received. Not only can future value and present value be computed, but other factors such as yield and rate of return can be determined as well, and compounding or discounting may take place on a less than annual basis, such as semi-annually or monthly. The relationship to the capital outlay decision evolves around capital budgeting and the analysis of whether or not funds invested today will be more than offset by the value of funds received from the investment in the future. Let's look at future value for a single amount. In determining future value, we measure the value of an amount that is invested now and allowed to grow at a given interest rate over a specified period of time. Notice the calculation on this slide. The relationship is expressed by a formula. You can use a financial calculator to derive the future value of a single payment by entering known values for number, interest, number being the number of interest periods, by the way, interest, the annual interest rate, the present value amount, payment, which would be entered as 0 in this case, and future value would be left blank. And then you would press the compute key and the future value key, and the resulting value will appear as a negative number. Here is the screen showing future value of $1 using a spreadsheet example. Take a look at this slide. When we're considering future value of a single amount, this slide illustrates the calculation if $10,000 were invested for 10 years at 8%, determining what the future value would be. We wish 8% was a realistic interest rate today, but it would equal a whopping $21,590. That's a happy thought. The present value of a future sum is the investment required today at a given interest rate that equals the future sum at a specified point in time. Notice on this slide another calculation. Here again is a visual depiction of the present value of $1 calculated out for 20 periods. And here we see a graphical representation of the relationship of the present value to the future value or future sum. If we look at how interest rate in single amount are calculated, when we know the future value, the present value in the time period, we can solve for the interest rate or the rate of return of an investment. We see an example of a calculation here using calculator keystrokes, or you could use an Excel spreadsheet to solve for the interest rate. Number of periods, single amount. Following up on the interest rate example, we can use formula 9-4 from your text to solve for the number of periods it takes to grow or compound $1,000 to $1,464.10 if we know the rate of return, which is 10%. Once again, using the spreadsheet example on page 263 or the calculator keystrokes, you can demonstrate how many years it takes to compound that $1,000 to $1,464.10. Future value of an annuity. An annuity represents a consecutive payments or receipts of equal amounts over equal time intervals. The annuity value is normally assumed to take place at the end of each period. The future value of an annuity represents the sum of the future value of the individual flows. Here we see a calculation for the future value of an annuity using a generalized formula. Now we have a graphic depiction of how the compounding process for that annuity works. And I think based on the formulas in the text and these slides giving you the visual, it should be extremely helpful. Here we see the future value of an annuity of $1. Part of the basis of this is that you're using a financial calculator to derive the future value of an annuity by entering the number of periods of interest, the annual interest rate, a present value, which would be 0 in this case, and PMT or payment. You would enter the periodic payment amount. Here we see the present value of an annuity. The present value of an annuity represents the sum of the present value of the individual cash flows. The formula for the present value of an annuity is presented in formula 9-6 in your text. And again, it involves using a financial calculator that involves entering the number of interest periods, entering the annual interest rate, leaving present value blank, entering the periodic payment as PMT, entering a futures value of 0, and pressing the CPT key and then the present value key with a resultant value appearing as a negative number, which is usually confusing for students. The annuity value associated with a present value is often associated with withdrawal of funds from an initial deposit or the repayment of a loan. Let's stop here and begin again with the time value relationship. See you again in Chapter 7, Part 2.